All right. Hello, everyone. Welcome back. All right. So this is the last part of the course. We're going to tell you how Prolog actually works. So what happens inside the computer. So it's sort of funny for a programming language when you say what actually happens in a computer is the last thing we see. But Prolog is like that, and Haskell is a bit like that too. So we can actually understand, what the program is meant to mean and what the result should be without knowing how it works. The reason we want to separate them out is because eventually we might want different ways of actually implementing them. We might want to implement them in the most efficient way that's possible that obeys the semantics. So we'd actually want to tell the computer exactly what steps to do. We'd like the computer to work that out for itself. All right. So we're going to start off with this idea of an instance of an atom or a clause. And what we're going to do is to uniformly substitute terms for variables. So we might have foo of x, y, x, and we might have an instance of this is foo of a. Okay? An instance of foo of x, y might be foo of a, z, and foo of a, b. Okay, so these are all going down, are all instances of each other. Okay, now we're going to write a substitution is a finite set of this form. Each variable gets related to this. So if I had foo of x, y, then I might have the substitution x gets replaced by a and y gets replaced by b. And if I apply this substitution, next thing I'm going to apply a substitution, I'm going to replace x with a and y to b. So then that's going to give us foo of a, b. Okay? Foo of xy with another substitution that says x gets replaced by z and y gets replaced by z gives me foo of z. Okay, so that's what these are substitutions, and this is a term, and this gets to be the result of applying that substitution. Okay, so that's what we just did then. The application of a substitution, we're just going to write them by writing them together. So sigma is a substitution, E is an atom or a clause. We're going to write E sigma is the instance of E with every occurrence of VI replaced by TI. So that's all we're going to do. All right. Now substitution is unifier if when we apply them, we're going to get the same thing. So for example, if we have foo of x and foo of za, a unifier is going to be x gets replaced by little a and z gets replaced by little a is a unifier. If we apply this to both of them, we'll both get foo of a. Okay? Now, most general unifier is a unifier, and if a substitution also unifies them, then it's got to be more general. Let's explain what's going on here. That might not make sense to you, so let's try and explain it here. So if we want to find foo of x and foo of zw, okay? One unifier of these is x gets replaced by z and w gets replaced by z. Okay? That's a unifier of them. Another one might be z gets replaced by x and w gets replaced by x. Okay, these are all unifiers because they make them identical at the end. So this one here becomes foo of zz, this one becomes foo of xz. Another unifier is x gets replaced by little a, z gets replaced by little a, and w gets replaced by little a. Okay, this is a unifier, but this is not the most general unifier. This is not a most general unifier. It makes more. So that's what this thing here is saying. So basically, when you apply them, so it's trying to make it so that these two are okay as most general, but this one is not a most general unifier. And so what we're trying to do here is this one here results in foo of zz. One results in foo of zz. 1 results in foo of XX. Okay, and that's what we're going to say, that if the substitution it also does it. You know, we can get from here to there by implying substitutions, or from there to there, but you can't get from foo of AA to there, back and forth. So that's why it's the definition we give. Okay, that's what we're trying to do. We're trying to make them unifiers, but not most general. All right. Turns out if there's more than one most general uniform, they only differ in the name of the variables. Like in the last one, they could just end up with foo of XX or foo of ZZ or foo of two variables that are the same. All right, so here's my procedure, unify T1 and T2. So let's try and apply this. Start off with I'll do an example. So I want to unify foo of XX with foo of ZA. Okay, so we're going to start off with E is going to be just foo of XX equals foo of XX is going to be equal to foo of ZA. Okay, so we're going to start off here. And my substitution is going to start off as empty. Okay, and we're going to just loop through this loop. So E is not empty. So we're going to select this variable. They're going to select this from it. So this is going to be little x. This is going to be little y. They're not identical. X is not neither is a variable. So we end up with this last case. And all we're going to do here is just say that the argument, this foo is the same on both of them. So now we're going to replace E with got to be x equals x. Sorry, x equals z. The first argument's got to be the same, and x has got to equal a. Okay, so this first argument's got to be the same, and the second arguments have got to be the same. Okay, now we're going to go through this. Now it's more interesting. Now x is a variable, so we're going to select and remove this one. So this is little x and this is little y. The first one is an argument. So what we're going to do is we're going to replace x, the big X, with z in both E and X. So we're going to replace it in here. So I'm going to replace this. So I'm going to, so we've removed this. Remember, we removed this, and this is what's there. So we're going to replace this with Z, and S becomes X is replaced with Z. So now we've removed this. Let's erase that. Okay, so we have E is this, is Z is equal to A, and X is equal to Z. Okay, now we're going to go through this again. We're going to select and remove Z is equal to A. And now that's what's going to be little x, so they're not identical. So x is a variable. So we're going to replace, everywhere we see z, we're going to place it with little a. And then we're going to add z for a gets in here. So s in here becomes, s here becomes x gets replaced by little a, and we're going to add z gets replaced by little a. And we've removed everything from e, and we can stop. Whoops. We can stop. Okay, so we can stop. And this is our final substitution. So this one here is our answer. X gets replaced by A and Z gets replaced by A. We'll give more examples in class. Okay. All right. So if you remember last time when we did the propositional case without variables, we searched backwards in a query to determine if it's a logical consequence. And we had this answer clause that said yes is true if this body. And it was weird about why we used this funny yes thing. And that's what we'll try and explain now. All right. So what we're going to do is we're going to have this resolution. We're going to have, this is my answer clause. We're going to, the idea is we get this answer clause, we select this first one, and then we select a clause with the first one. So we find in this knowledge base, this AFB1 to BN. So you find something that these two are identical. And all we're going to do now is get a new answer clause where this B1 to BK comes from here, the body, and this is the rest of the clause, goes to there. Okay, and it's yes. And we just, right, and we just keep repeating that. That's our proof procedure. Okay, and here's the proof procedure. So now what we're going to do is now we're going to think about with variables. So what we're going to do is we're going to do some little trick here. The reason we're using x is we can have these. These are going to correspond to the answers that we're going to give in the end. So an answer clause has this arguments of t1 to tk with their terms, and these are now going to be atoms in the same thing way we had them before. Right. So now what we're going to do is now we're going to select this A1 that said before. Now we're going to select a rule here that with A as the head. Now what we have to do is must have to unify. Right? So A1 and A have to unify. Okay? And we're going to do the same thing we did before. We're going to take the body of the clause in the database. We're going to place A1 with that. And we still have the rest of this down here. And the trick is what we're going to do is we're going to apply this substitution because we have to make sure that A1 and A are identical. And theta will do that, and that's going to let this work. Okay. All right. So that's what's going to let this work. So here's the previous one. We answer the clause with Q if Q1 to QK. We're going to say yes if here's my query. And we're going to select the leftmost atom in the body. We're going to choose a clause and we replace the body with the atom with the body. We're going to repeat that until we get an answer. So here is the one with variables. So what we're going to do is when we first of all start off with a query, B, this body, and it's got these variables, we're going to say yes, and we're going to put those variables as arguments to the yes. So these are actual variables in the query. And we're going to say yes, yes, the answer is V1 to VK if B is true. And now we're going to repeat again, we're going to do this. We're going to an answer clause here is going to be this form. Yes, if T1 to TK and this A1 to AM. So we're going to select this leftmost atom in here. We're going to select this A. All right. Now we've got one trick that we have to do before we do this. So we're actually going to find a clause and then we're going to rename all the variables in it. We sort of got to get a copy of the clause. Otherwise we sort of get into trouble because variables sort of are local to it. So that's the only trick here is doing that. And these two have to unify, right? And they're going to unify with a substitution theta. We're going to fail if they don't unify. Okay. And we're going to do the same thing we did before, is we're going to take the body of A. We're going to put that there. We're going to, these ones here are the remainers. So we now have to prove B1 to BP and A2 to AM. Okay. And now we're going to apply this substitution to everything. We're going to do that. All right. Now, when we loop this for a while, then we get to this, we get to the empty body, and we end up with yes if T1 to TK, and Prolog prints this out. V1 is equal to T1. It knows this is an answer, and VK is equal to TK. That's the answer. All right, so here's an example here. So here's the parent database we did in the first class with Prolog. And we're going to give this query to grandmother Estelle X. So we're first of all going to say yes, X, if grandmother Estelle, I'll try Estelle X. We're going to find a rule for it. We're going to say yes. All right. Now, notice this X here, before we do this X here is different to this X here. So this X here and the grandmother is a different X. We don't want them to mix them up. Okay, so with this clause in the database, we don't want to mix all the clauses. What we're going to do is rename them. Let's rename them X1, Z1, and Y1. Okay, Prolog just uses random numbers. You see something like underscore 1, 2, 3, 4. But we're just going to put X1 and Z1. Okay, now we're going to unify these two. So X1 is going to be replaced by Estelle, and X is going to unify with Z1. So I'm going to say yes, let's keep it as X if mother Estelle of Y1 and parent of Y1 is X. Okay, I just rename them so that it's the same X here, but Prolog doesn't care what they're called. It just treats them as internal numbers. Okay, we're going to try now. We're going to select this one. We're going to find something that unifies with Mother Estelle, and we'll find that it's Sophie. So y1, so this is going to unify with this, with y1 becomes Sophie. I'm just going to replace it with a body, and it's because this has nothing there, we're going to remove it. So it's going to say yes, the answer is X if parent Estelle, whoops, that's not right. If parent Y1 gets replaced by Sophie, so Sophie of X. So we're looking for someone who X is the parent, so Sophie is the parent of. Okay, now we're going to unify this with a copy of this clause, and remember we're going to rename the variables. Let's rename them to X, say X2 and Y2. Okay, now we're going to say yes, yes, the variable X is true if mother Sophie of X. And now we're going to try to unify that, and we're going to find Xavier. So it's going to say yes, Xavier. And now the answer is going to be X equals Xavier, and the product's going to print this out. Okay. All right. That's all. We'll give more examples when we in class. Thanks for listening.